They are murders no one remembers. Crimes committed so long ago that the detectives who first worked the scene have retired or died. The evidence has sat in cardboard boxes for 3 decades, and the victims' families have learned to grieve without resolution. For most of the 20th century, these cases were considered closed in every practical sense, their files yellowing in manila folders stacked in property rooms no one ever checked. The technology to solve them simply did not exist. Then something changed. Ordinary people began mailing tubes of saliva to consumer ancestry companies to find out where their grandparents came from. They had no idea they were also building the most powerful criminal identification tool in the history of forensic science. The science underneath every consumer DNA kit operates on a straightforward principle. 2 people who share a common ancestor also share identifiable segments of genetic material. The closer the relationship, the more DNA they carry in common. A parent and child share roughly 50%, siblings average about the same. But even distant cousins, people who may never have met and share only a small fraction of their genetic heritage, still carry matching fragments that a computer can detect and measure. When millions of people upload their raw genetic data to public platforms hoping to find lost relatives or trace ancestry lines, they create a searchable map of biological connections that extends across entire extended family networks. That map, it turned out, could be walked backward. Forensic genealogy exploits exactly this principle. When investigators hold a DNA sample recovered from a crime scene but cannot find a direct match in any law enforcement database, they convert that sample into a format compatible with consumer ancestry platforms. The genetic profile does not need to match the perpetrator directly. It only needs to reach someone related to them. If a distant cousin has voluntarily uploaded their data, investigators can begin building a family tree outward from that match, tracing relatives and descendants forward through census records, birth certificates, marriage indexes, and obituaries until the branches of the tree narrow toward a single individual who fits every other known detail of the crime. The person credited with pioneering this methodology at scale is Barbara Rae-Venter, a retired patent attorney who had spent years mastering the craft of investigative genetic genealogy before law enforcement came to her. When investigators handed her a cold case profile extracted from decades-old crime scene evidence, she did not wait for a direct match that might never arrive. She searched for distant relatives, individuals sharing less than 1% of their genome with the unknown subject, and she began the painstaking process of reconstructing the family trees those cousins belonged to. She mapped lineages backward to their common ancestors, then traced every descendant forward in time, applying filters to eliminate branches that could not plausibly match the suspect. Male, born within a specific decade, living within the geographic footprint of the attacks. Gradually, a sprawling network of thousands of relatives collapsed into a handful of names. This was not forensic proof. Family trees built from public genealogy databases cannot stand alone as evidence in a courtroom. What they provided was something law enforcement had not possessed in 40 years of searching: a starting point, a direction. For cold cases that had long been declared unsolvable, a genealogical lead represented a complete reversal of investigative momentum. The case that demonstrated this capability to the world involved a man who had terrorized 2 separate regions of California under 2 separate names for over a decade, without anyone in law enforcement realizing both waves of violence were the work of the same person. In Northern California during the late 70s, he became known as the East Area Rapist. He selected single-family homes in newly built subdivisions that backed onto green spaces, drainage canals, and school grounds, using those hidden corridors to approach properties and escape without detection. He developed behavioral rituals so specific and repetitive that investigators eventually used them as a fingerprint. He bound his victims using materials he found inside their own homes. When couples were present, he would stack dishes on the restrained man's back, warning that a single rattle would be the signal for an execution. Months after the attacks, some survivors received phone calls in the night where the caller said nothing, or whispered just enough to confirm he had not moved on. When the assaults in Northern California went quiet, a new pattern emerged hundreds of miles to the south. In the coastal and suburban communities of Southern California, couples were being targeted inside their homes and killed. Local investigators working these homicides had no reason to suspect any connection to crimes occurring at the other end of the state. The escalation from assault to murder, the geographic distance, and the absence of any agency coordinating across jurisdictions meant that the two sets of crimes were treated as entirely unrelated threats for years. It was only when analysts began plotting all the attack locations on a single state map that the tactical consistency became undeniable. The offender had selected the same style of residential property in both regions, backing onto the same type of access corridor, applying the same restraint methods. The evidence indicated the same individual had simply continued south and kept going. DNA preserved from the earliest crime scenes had been tested against every available law enforcement database. The results were always identical. The profile existed. The match did not. The perpetrator had never been entered into any criminal DNA system, which meant no matter how carefully the sample had been maintained or how precise the laboratory analysis, the database had nothing to return. The investigation had reached the outer boundary of what conventional forensic tools could accomplish. The shift came when investigators converted the crime scene profile into a high-density genetic format and uploaded it to GEDmatch, a public platform where Ancestry enthusiasts had voluntarily deposited their raw DNA data. Within that database, the search located distant relatives of the unknown subject, ordinary people with no criminal history and no connection to any investigation, who happened to share genetic segments with the perpetrator of these crimes. Rae-Venter built family trees from those distant matches outward and then inward, working through historical records and public documents until the candidate pool narrowed to a single name: Joseph James DeAngelo. A former police officer in his 70s, living in a quiet suburb of Sacramento. Genealogical identification cannot stand alone in a courtroom. To make an arrest, investigators needed physical evidence that could confirm the connection beyond any reasonable doubt. They placed DeAngelo under surveillance and waited. When he left a coffee cup and a trash bag on a public street outside his home, investigators recovered both legally without a warrant, because material discarded in public is classified under law as abandoned property. The DNA extracted from those items was then compared directly against the profile preserved from the original crime scenes. The match was exact. 40 years of investigation resolved into a laboratory result. The broader reach of this methodology extends well beyond any single case. Forensic genealogy has since been used to identify victims of homicide whose names had been unknown for years, returning identities to families who had been told only that an unidentified person had been found. It has closed cases in multiple states where perpetrators had relocated and changed their circumstances entirely. In every application, the process follows the same underlying logic. Biological information shared voluntarily by ordinary people for private purposes becomes the raw material of criminal investigation. This has raised serious debate that remains unresolved. When a person uploads their genetic data to a public platform, they are simultaneously uploading information about every biological relative they have, including relatives who never agreed to participate and never consented to being searchable by law enforcement. Because DNA is inherited, one family member's decision radiates outward through an entire biological network. Platforms that host this data have responded by modifying their access policies, requiring users to explicitly opt in to law enforcement searches rather than making participation automatic. But the underlying technology cannot be dismantled. The transformation of consumer genetics into a forensic instrument has forced a fundamental reconsideration of what privacy means when the human body itself continuously generates identifying data. Crimes that were deliberately designed to outlast the investigative capacity of their era, executed by perpetrators who relied on the limits of the forensic tools available to them, are now being resolved by biological echoes those perpetrators left in their own relatives. The cases that were meant to stay cold are not staying cold, and the database that made them